Hello and welcome to Maths by SAS. This is my first lesson of D1 chapter number 1 exercise 1A, that is about the prime and composite numbers. Before going to the lesson, there are some key points that I want to discuss. That what are the prime numbers and what are the composite numbers. Prime numbers are the numbers which have only two factors. One is the number 1 and other is the number itself. Suppose I'm taking the example of 3. 3 has only two factors. One is the 1 and the other is the number itself. And the composite numbers are the numbers which have more than two factors. Like if I'm taking the idea of 9, 9 has three factors. 1 is the factor of every number. 1, 3 and 9. So the numbers which have only two factors, okay, they are the prime numbers, and the numbers which have more than two factors, they are composite numbers. If you find any difficulty in understanding the types of numbers, you can watch the lesson that I'll be giving in the description box, because the classification and types of numbers are not important only D1 chapter number 1. But in many other topics in the later classes, like linear inequalities, and then the sets and probability as well. So you should have the good grasp on these all concepts. So let's move to basic level question number 1. And question 1 says, determine each of the following is a prime number or a composite number. There are some numbers given to us and we have to decide whether they are the prime numbers or they are the composite numbers. And how are we going to decide? For that purpose, we should have good command on the divisibility test. Again, if you're not good at divisibility tests, you can watch the lesson that link will be given in the description box for the divisibility test as well. So let's think about 87, how we are going to decide that 87 is a prime number or a composite number. We can see that the unit digit is 7, that is odd, it's not divisible by 2. So the whole number, the complete 87, will not be divisible by 2. Let's check divisibility test of 3, and divisibility test of 3 says that we have to add up the digits which are given in the number, like 8 plus 7, and the sum comes 15. If the sum is divisible by 3, then that number will also be divisible by 3. So the possible factors of 87 can be 1 and 87. And let's test 3. Whether 3 divides 87 or not. 3 2s are 6, and 3 I have to bring 2 down, and 3 9s are. So the factors that we are getting for 87 are 1, 3, and then 29 and 87. So it means it's a composite number. 87 is a composite number. You can see, students, that how we are deciding that the given number is a prime number or a composite number. Moving to the second number, which is 67. Again, focus attention on the unit digit. It's not 2, it's not multiple of 2. So there is no reason that this number can be divided by 2. Moving to test of 3. Add up the digits. 6 plus 6 is 7. Plus 1, 13. 13 is not divisible by 3, so it's not divisible by 3. Moving to 4, the unit digit is not even, so it will not be divided by 4. For divisibility test of 5, the unit digit has to be 0 and 5, so it's not divisible by 5. 6 is even, so not possible. Okay, so it means it's a prime number. It's a prime number. Okay, moving to 73. 73 is an odd number. Unit digit is not 2, not multiple of 2. So there is no reason that it will be divisible by 2. Moving to 3, add up the digits of the number. 7 plus 3 is 10, and 10 is not divisible by 3, so there is no reason that we can divide this number by 3. Then 4 not possible, 5 not possible, because for 5, if the number is divisible by 5, then the unit digit must be 0 or 5, so it means it's not divisible by 2, 3, 4, 5, and 6 not possible, so it's a prime number again, prime number. Coming to 91, 91, the unit digit is 1, that is not even, it's not multiple of 2, so we cannot divide this number by 2. And now if I'm adding up the digits, 9 plus 1, 10, 10 is not divisible by 3, so this 91 is not divisible by 3. Then coming to 4, not possible, 5 not possible, because unit digit has to be 0 or 5, 6, and if I'm checking it for 7, 7 is 13, 7s are 7 13 times are, so it has at least 3 factors with us, 1, 13, 7, and 91 itself, so it's a composite number. I hope students you are really clear that how we are deciding. We are not simply making the decision by looking at the number. We are applying the divisibility test in order to make a clear decision whether the number is a prime number or composite number. Moving to the second question, and the second question says, find the prime factorization of each of the following numbers, leaving your answer in index notation. Okay, one thing is that we have to understand the meaning of the term prime factorization, and the second is that we have to understand that what is the index notation. Index notation. Okay, so first of all we have to understand that what is factorization and factor. What are the factors? Okay, factors are the numbers. Factors, they are the numbers which when we multiply together we get the number back. Factors. Then the second thing is factorization. Factorization, T-I-O-N. Factorization is the process of expressing a number as the product of factors. Okay, factorization is the process of expressing the number as a product of its factors, and prime factorization means in the process in which the factors are the prime numbers. And the last thing is that we have to give the answer in index notation. Okay, suppose we have the expression like 2 multiplied by 2. What we can do is, how can we express this in short form? That 2 is multiplied by 2 itself 2 times, so we'll be writing 2 once, and we have to mark 2 at the top. That will be telling us that 2 is multiplied by itself 2 times. This is the index notation. So first we have to go for the prime factorization of 72, and for that purpose we have to make this formation 72, and as we have to go for prime factorization, so always choose the smallest prime divisor. Do not go abruptly, do not pick up composite numbers, and do not start with the largest factor. Like we can begin with 2, and we have to see 2 how many times is 72, which is 36, and then again we can divide. 36 is an even number, unit digit is divisible by 2, so 2 18s are, and then 2 18s are, 2 9s are, and then you can see, students, that I'm not picking up the factors abruptly. I'm going in sequence. Okay, 3, and then 3 how many times is 3? 3 1s are 3, and I have to complete the working here. 3 1s are 3. So 72 as the product of prime factors. First we have to write down all the factors. 2 is coming how many times? 2 multiplied by 2 multiplied by 2, multiplied by 3 multiplied by 3. Now look, 2 is coming how many times? 2 is coming 3 times. 2 raised to power of 3, which is 8 multiplied by 3 square. 8 multiplied by 9, and we are getting our answer back, which is correct. Okay. Moving to the second part, which is 187. 187. So let's talk about that which one will be the smallest prime factor, prime number that will be dividing 187. Okay. Then if we think about 2 not possible because the unit digit is not 2, not multiple of 2. Checking the divisibility test of 3. 8, what we have to do, we have to add up the digits. 1 plus 8 plus 7. Okay, 8 and 1 9 and 1 10 and 6 16. Sum of the digits is 16, which is not divisible by 3. So 187 is not divisible by 3. For 4 and 5, not possible because for 5 the unit digit has to be 0 or 5. 6, not possible. If I'm checking for 7, 2s are 14. 14 not possible. Then if I'm checking 9 not possible, 10 not possible, and let's give a trial for 11. 87 divided by 11. 11 one times and 7, so 11, and then I will left with 17, and 17 ones are 17 ones are. Okay, so the factors and prime factorization for 187 are 11 times 17 times 1, and we cannot write it in the form of the index notation because all of the factors are coming once only. So it means that we have to stop our working at this stage. Moving to the third part, which is 336. Okay, 336. So for that purpose, what we are going to do is that first of all, start making your mind that which smallest prime number is suitable for the given number. I'm going really slow in these lessons because basically I'm making these lessons for my class 6-7 students, my bacha party, and then my O1, O2 and O3 students can also get benefit from these lessons. Okay, as the unit digit is 6, which is even, and that is divisible by 2, so the 336 can easily be divisible by 2. Okay, now look, 2 ones are 2. Okay, and I'm left with 1. That 1 will be given to 3, and it will become 13. 2 6 are 12, and 2 8s are 16. Okay, in these all lessons I'll be going really slow, and I'll perform all of the calculations mentally because I want to teach my students that how to perform the calculations mentally, because these questions are coming mostly in paper 1. 2 8s are 16 and 2 4s are, and again what we can do is that 84 is an even number. 84 is an even number, so we can further divide this number by 2. 2 how many times? 2 4s are and 2s are. Again the unit digit is even, so we can divide this number by 2. 2 2s are and 2 1s are. Sorry, and do not go abruptly. Do not pick up any factor. Please go in a sequence. 3 7s are and 7 1s are. 7 1s are. So okay, now I have to write 336 as the product of their factors. 2 is coming 1 2 3 and 4 times. 2 1 2 3 and 4 times, and then 3 is coming once, and 7 is coming once, and 1. Okay, now in index notation, 2 raised to power of 4 multiplied by 3 multiplied by 7, and then 7 3s are 21 multiplied by 16. Let me check it once again. Yes, 336, and this is the correct answer, and I'm getting the index notation here. And the last part of this question is 630. Okay, 630, again think about the smallest prime number that will be dividing 630 easily, and as the unit digit is 0, so we can easily divide this number by what number, students? Okay, now by now the divisibility tests have to be really clear. As unit digit is 0, so we can easily divide this number by 2. Okay, and let me make some diagram here, complete some portion. 2 how many times? 2 3s are 6, 2 1s are, and 1 I have to give to this number, and 2 5s are 10. Okay, now look, unit digit is not even number, or it's not divisible by 2, so we cannot go for 2. And what we have to do is that we have to think about some other number that can easily divide this 315. And now 5 plus 1 6 plus 3 is 9. 5 plus 1 6, 6 plus 3 is 9. As the sum of the digits is divisible by 3, so the 315 will be divisible by 3 easily. 3 how many times is 31, or closer to 31. 3 10s are 30, and 1 will be given to 5, and 3 5s are. Again, unit digit is 5. I cannot divide this number by 2, so first I have to think about table of 3. Add up the digits. 5 plus 0 is 5, plus 1 6. As 6 is divisible by 3, so the number 105 will also be divisible by 3. 3 how many times is 10, or closer to 10. 3 3s are 9, and 1 will be given to 5. 3 5s are 15. Okay, now what we have to do is that again the unit digit is 5, not divisible by 2, so we have to first think about table of 3. 5 plus 3 is 8. Sum of the digits is not divisible by 3, so we cannot think about table of 3. Then 4 not possible. 5 how many times? 5 7s are, and 7 1 times. You can see, children, that I'm going in a sequence. I'm not picking up the abrupt factors, okay, and I'm not picking up the composite numbers, okay. And then what we have to do, we have to write our answer in index notation. So I have to see 2 is coming how many times? Once, and then 3 multiplied by 3, and 5 multiplied by 7 multiplied by 1, and 2 multiplied by 3 square multiplied by 5 multiplied by 7, and then 9 multiplied by 10 is 90, and 97s are 9 7s are 63. So it means my working is correct. And moving to the next question, and that says find each of the following by using prime factorization. So the first part is try to understand the meaning of this symbol, that we have to find the square root of 1764 by prime factorization. So first of all, we have to go for the division of 1764, okay, and then we have to go for the square root. We'll be discussing it later, that how we are going to find the square root of that number 1764, okay. Then I'll give you the trick as well, that how you can like assess your working is correct. 1764, again we have to apply divisibility test. We can see the unit digit is 4, that can be easily divided by 2, so this number we can divide this number by 2. 2 how many times is 17, and closer to 17, 2 8s are, and then that 1 will be given to this 6, 2 8s are, and 2s are. Again this number is divisible by 2 because the unit digit is 2, 2 4s are, 2 4s are, and 1s are. Now at this stage we cannot divide this number by 2. And why we cannot divide this number by 2? Because this is 1, this is odd number, it's not a multiple of 2. Okay, so first let's think about divisibility test of 3. 4 plus 4, 8 plus 1, 9. 9 is divisible by 3. It means this number will be divisible by 3. 3 ones are, and then 1 will be given to 4. 3 fours are 12, and 2. 3 sevens are 21. Okay, now let me once again check it. 3 ones are 3, and 14. 3 fours are 12, and 2. 3 sevens are 21. Again, let me check the test of 3. 7 plus 1, 8 plus 4, 12. So this number is divisible by 3. 3 fours are 12. Okay, 2 and 3 nines are 27. And then what we have to do, we have to think about the number that can easily divide 49. 49, for 49, we can see the table of 7 is very much suitable, and 7 one time. Okay, so first of all, I have to write 1764, and I have to write the factors in form of the product. 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 7 multiplied by 7. Now what we can do is that we can see that 2 is coming how many times? That is 2 square. 2 square multiplied by 3 square multiplied by 7 square. And then let me go up, because I feel that my working is not coming under the camera. 1764. Actual requirement is that we have to find the square root of this. Okay, 1764. Okay, look children, do observe my working carefully, that in the beginning I'm not putting the square root symbol here. At this stage, when I'm putting the square root symbol here, on the other side I also have to put 2 square multiplied by 3 square multiplied by 7 square and raised to power of 1 by 2. And now what we can do is that we can write it in the form 2 square multiplied by 3 square multiplied by 7 square raised to power of 1 by 2. Now look, all the factors have power 2 same or common. We can pull it out, we can write it outside. I will left with 2 multiplied by 3 multiplied by 7, 2 multiplied by 1 by 2. This will go, and I will left with 2 times 3 times 7. 7 3s are 21, 2s are 42. 42 is the number whose square is 1764. Here one thing that I want to teach to my students is that for the number to be a perfect square, the index of each prime factor must be the multiple of 2. You can see that here when we are expressing 1764 as a product of prime factors, every factor has the power 2. Okay, we can easily extract it out, pull it out, and we can simplify that with this 1 by 2, and then the base, then the number which is inside the bracket, that becomes the answer for that. Moving to the second part, that is 576. First, what we are going to do is that we have to make the prime factorization. At this stage, I also advise it to my students that you should have good command on this basic perfect squares 1 till 30. That will also be helping you in deciding whether your working and answer is correct or not. And the cube from 1 till 10. So 576, first I have to make the prime factorization of this. Again, unit digit is 6, which is even, so I can divide easily this number by 2. 2 how many times is 5 or closer to 5? 2 2s are 4. I will left with 1, that 1 will be given to 7. 2 8s are, and 2 8s are. Okay, 2 2s are 4, 2 8s are 16, and 2 8s are 16. Again, unit digit is even, multiple of 2. I can divide this number easily by 2. 2 1s are, 2 4s are, and 4s are. Okay, again a unit digit is 4, so we can divide it easily by 2. 2 7s are, and 2 2s are. Okay, then I hope table of 2 will be going throughout. 2 how many times? 2 3s are and 6 are. I'm going really slow so that my junior students of class 6 and 7 can get benefit from these lessons. 2 18s are. 2 18s are, and as this is a square root, so all of the factors must be having the index either 2 or multiple of 2. This is also one of the trick. 2 9s are 18, and then what we can do is that for 9, table of 2 is not suitable. 3 3s are and 3 1s are. 3 1s are. Okay, now 3 1s are. Now what first we have to do is that we have to write 576 as the product of its factors. 1 2 3 4 5 6. 1 2 3 4 5 6 multiplied by 3 multiplied by 3 multiplied by 1. Now look, what we can do is that 1 2 3 4 5 6 2 raised to power of 6 multiplied by 3 square. Okay, now I have to find the square root of this number, so let me go up and let me use different pens so that my students can see the difference. I need to find the square root of 576, so I will be putting square root symbol on both sides. Now 2 raised to power of 6 multiplied by 3 square, and for the calculation purpose I will be writing it in the form of fraction. 3 square raised to power of 1 by 2. Okay, now we can take this power 2 of every number inside the bracket multiplied by 3 square multiplied by 1 by 2. Okay, let me make some line here. Then 2 1s are and 2 3s are, and we are left with 2 raised to power of 3 multiplied by 3. This 2 goes with this, and this is 2 raised to power of 3 8 multiplied by 3, which is equal to 24. 24, yes, 24 is the number whose square is 576, so square root of 576 will be 24. Students, I hope you are really clear about today's class. In this class we have learned that how to decide the type of numbers, classification of numbers, that whether the number is a prime number or a composite numbers, by applying the tests of divisibility, and then we have to find the prime factorization of the given numbers, and expressing the numbers in index notation, and then we have to find, we learned how to find the square roots of different numbers, and the technique for finding the square root of any number is that if a number is a perfect square, then the index of each prime factor must be the multiple of 2. Okay, please watch my lessons, like, share and subscribe the channel, and press bell icon to get the notification of every lesson in time. Thank you very much.